Hello, my dear students. Good afternoon. Welcome to the class. Myself, Bhagyashree Joshi from Sankalp Learning Solutions. Okay. Yes, dear students. Today we will learn the chapter that is circles. Okay. What do you mean by circles and which parts we are going to observe in the circle? And here two theorems are there. That is also very important as far as our examination is concerned. Okay. Yes. Shall we start today's session? Circles. So in day-to-day life, we are observing circles. So in so many situations, we are observing circles. Okay. So what do you mean by circles then? Already we have learned this. So what do you mean by circle? Okay. See, if I draw like this, see, this is a fixed point. And if I draw a points around the fixed point, so that means this is the collection of all points from a fixed point. Okay, or it is a equidistance from a fixed point. The locus of all points, that means collection of all points from a fixed point, that we call it as a circle. Okay, next, which parts you are going to observe in the circle? That is, first one is radius. See, this is a fixed point, that is center of the circle, that we denoted by the letter O. You can take any letter. So do O, the distance between any point on the circle and the center O is called radius. And the line which is passing through the radius and center of the circle, the line which is passing through the center of the circle, that we call it as a diameter. And always diameter is 2 times that of radius. Okay, if you consider radius is r, that is d is equal to 2r. Okay, and this part is chord. Okay, if we join any 2 points on the circle, that line we call it as a chord. And this part, the part which the area between the area which is enclosed between the chord and the arc. See, this part we call it as a arc. Okay, this part we call it as a arc, and the area enclosed between chord and arc we call it as a segment. Okay, next. See, this is sector, segment. Then what do you mean by sector? Sector means if I draw one more radius, see this is one radius, and if I draw one more radius, the area enclosed between two radius, that means this part, the area enclosed between two radius, we call it as a sector. Okay. Next, this is segment. This is arc. Okay. This part we call it as a arc. And if you draw one line which touches the circle at a particular point, that line we call it as a tangent. Okay. Next, this line is a chord. And circumference. What do you mean by circumference? Circumference means, in other words, it is called as perimeter. Okay. So what is circumference? Circumference means outer boundary of the circle. See, this is outer boundary. Yes or no? This is outer boundary. So outer boundary of the circle. See, if you consider this is a circle, then outer boundary of the circle, we call it as a circumference. Okay. So this part we call it as a circumference. Then what is the formula to calculate circumference of a circle? That is 2 pi r. Okay. Next is diameter. The line which is passing through the center of the circle, we call it as a diameter. And the biggest chord, okay, biggest chord in the circle is diameter, or it is, in other words, it is called as longest chord. Okay. Longest chord in the circle is diameter. And if you draw a line just touches to the circle, that line we call it as a tangent. In this year, you are going to study about the tangent and sectors. Okay. Yes. Next comes, see here, three circles are there and one line, PQ line is there, and three circles which is having center A, B and C. Okay. So this is a circle which is having center A, and this is a circle is having center B, and this is a circle having center C. Okay. Next. Here one line is there, that is PQ. That PQ line is called as non-intersecting line. Why it is called as non-intersecting line? Because the line PQ and the circle have no common point. See here, is they have any common point? No, because it is not touching the circle which is having center A. Okay, so the line PQ and the circle have no common point. In this case, PQ is called a non-intersecting line. Okay, PQ is a non-intersecting line for the circle of center A. Next, second. What do you mean by second? This is also very important. Second and tangent. There are two common points M and N that the line PQ and the circle have. In this case, we call the line PQ a secant of the circle of center B. See here, a line which is passing through the circle having center B, and this line it intersecting at point M and N. Yes or no? It intersecting a point M and N. So this line we call it as a secant of the circle. So PQ is a secant of the circle of center B. Okay. Next, tangent. There is only one point O which is common to the line PQ and the circle. In this case, the line is called a tangent to the circle of the center C. Now observe the circle which is having center C, and this line PQ, it touches or intersecting at point O here, right? That means at one point only it is intersecting, right? And this line PQ, we call it as a tangent to the circle having center C. Okay, so this is a tangent. Next comes, so here, based on this tangent and second, we are going to solve some multiple choice questions. Yes, shall we start to solve multiple choice questions? Yes, first question is, a straight line which intersect a circle at 2 points. See here, the straight line PQ, it is intersecting at 2 points. So this line we call it as a secant. That means a straight line which intersect a circle at 2 points is called as secant. This question was asked in previous year examination. Okay, second. The number of points in which a tangent touches a circle. In how many points circle will touch the circle, or tangent touches the circle? That means at only 1 point. Okay, at only 1 point. See here. If you draw like this at this point, if you draw like this at this point, that means only 1 point it is intersecting a circle. Okay. Next point. Next question is the number of tangents that a circle can have. Yes, how many tangents circle can have? Circles can have infinite number of tangents. Yes, you can draw any number of tangents to the circle. Okay, so infinite number of tangents it has. The maximum number of parallel tangents that a circle can have. Maximum number of parallel tangents. Okay. This is 1, 2, 4 and infinite. This is also infinite number of tangents. Okay. The common point between the circle and the tangent of a circle is called, whether it is a center, no, because center is the center of the circle, and external point, none of this. So of contact, that we call it as a point of contact. Yes, the common point which is between the circle and the tangent is point of contact. The length of the tangent drawn to the circle of radius 3 centimeter from a distance 5 centimeter from its center is, okay. The length of the tangent drawn to a circle of radius they have given. Okay, so this is a circle. See, this is the center of the circle and this is a radius. Okay, so radius they have given. Wait for a minute. Yes, so radius they have given, that is 3 centimeter, and 5 centimeter from its center. That means this is a center and this is 5 centimeter from a center is 5 centimeter. Okay, the distance is 5 centimeter from the center. Call this as point A and this is B. Okay, now OAB is a triangle and it makes a 90-degree here. Okay, it makes a 90-degree. So when a line which is perpendicular to the radius circle, that is, it makes a 90-degree here. Now, here it is 90-degree and the line OB is 3 centimeter and OA is 5 centimeter. Now, by using Pythagoras theorem, you can say that here, this is 90-degree means this is hypotenuse, right? This is hypo. So hypotenuse square, that is OA square is equal to OB square plus AB square, right? OA square is equal to OB square plus AB square. Now, what we want AB value. AB value we don't know. OA, that is 5 centimeter. OB is 3 centimeter. But what we want AB. So for that, what I will do? I will transfer this OB to this side. So OA square minus OB square is equal to AB square. Okay. So AB square is equal to OA is 5 square minus 3 square. That is 25 minus 9. So AB square is equal to 25 minus 9 is 16. So AB square is equal to 16. That means AB is equal to square root of 16. So AB value is actually square root of 16 is 4. This is plus or minus 4. But side of the triangle cannot be a negative. Therefore, we are taking only positive value. That means this is 4 centimeter. B is 4 centimeter. The length of the tangent. Okay, so this is 4 centimeter. Option B is right. Next one. If the length of the tangent drawn from an external point Q to a circle is 24 centimeter and the distance between the point Q and the center of the circle is 25 centimeter, then the measure of the radius is, see here what they have given, one circle is there. In that circle, one center is there, right? So length of the tangent drawn from an external point Q, that is external point is Q here. 24 centimeter and the distance between the point Q and the center of the circle is 25 centimeter. So this is 25 centimeter and the line tangent drawn from an external point. So this is a tangent. Yes or no? This is a tangent. This is a tangent PQ. Okay, so this is O. Now, here it makes a 90-degree right angle triangle. That means at point P, this is 90-degree. So this is 24 centimeter and OQ is 25 centimeter, right? Now, by Pythagoras theorem, here also Pythagoras theorem can be used. Why? Because this is a right angle triangle and you know the values of two sides. So by Pythagoras theorem, the side opposite to the 90-degree, that is hypotenuse is OQ. So OQ square is equal to OP square plus PQ square, right? OQ value is 25 square. OP square, we don't know. PQ square is 24 square, right? Now, transfer this 24 to this side. So, OP square is equal to 25 square minus 24 square. Yes or no? Now, OP square is equal to 25 square is 625 minus 24 square is 576. So OP square is equal to 625 minus 576. The value is 49. So OP square is equal to 49. Then what is the value of OP? OP is square root of 49. That means square root of 49 is 7 centimeter. So here option A is right. That is 7 centimeter. Understood? Shall we move to next question? Yes. Next question is, in the figure, POQ is equal to 110 degree. Okay. If TP and TQ are the tangents to the circle with center O, then the measure of PTQ. Yes, my dear students, observe carefully. Such type of questions will be asked in the examination for 1 mark, or it may ask for 2 marks also. But definitely one question they will ask, right? So here POQ value they have given, that is 110 degree. Yes or no? POQ. O is the center here and OP and OQ are the radius, right? Next, T is the external point and TP and TQ are tangents. So TP and TQ are tangents to the circle with the center O. Then the measure of PTQ we want, right? PTQ. So this angle we want, right? O angle. POQ is 110 and PTQ we want. For that, what we will do? So we know one relation, that is the angle between the radius, the angle between the radius, the angle between the radius plus angle between tangent. Angle between tangent is equal to 180 degree. Remember, angle between the radius. So this is the angle between the radius and this is the angle between two tangents. That's equal to 180 degree. Now, angle between the radius is POQ, right? POQ is the angle between the radius. PTQ is the angle between tangents. So 180 degree. Now POQ is 110 plus PTQ is equal to 180 degree. Transfer this 110 to this side. Then PTQ is equal to 180 minus 110 degree. That is equal to 70 degree. So option B is right. Okay. Yes, next question is if the angle between the tangents PA and PB drawn from an external point P to a circle with center O is 80 degree, then the measure of POA, see my dear students, this is an external point P. Okay, one circle is there that is having center O. Okay, now from external point we are drawing two tangents, that is PA and PB, right? PA and PB. Okay, so this is external point P and PA and PB are tangents and center O. Now, so what they have given? So the angle between the tangents they have given, that is 80 degree they have given. And what they ask, the angle between the radius, that is POA, they have asked. POA they have asked, right? So P. Angle between the tangent is angle APB, right? APB plus angle between the radius AOB, right? AOB. Angle between the radius is AOB is equal to 180 degree, right? And what they have given, that angle between the tangents they have given, that is 80 degree plus AOB, right, is equal to 180 degree. Now, AOB, angle AOB is equal to, transfer this 80 to this side. So 180 degree minus 80 degree, that is equal to 100 degree. So angle AOB is 100 degree. But what we want? We want POA. Observe carefully. Angle AOB is 100 degree. Then what is POA? POA is exactly half of the AOB, that is 100 divided by 2. 100 divided by 2 is 50 degree. So POA is 50 degree and POB is 50 degree. So option B is right. So next question. If the length of the tangent drawn from an external point A is 5 centimeter away from the center of the circle is 4 centimeter, then the length of the radius they have asked. See, what they have given, one circle is there. One circle is there and one external point is there, and the length of the tangent drawn from an external point A. So this is point A is an external point and we are drawing a tangent here, and length of this tangent is 5 centimeter, right? Next, from away from the center of the circle is 4 centimeter. So center of the circle is here. So this is 4 centimeter. So this is center O, this is A and this is B. Now, here it makes an angle 90 degree. Here also by using Pythagoras theorem, we can say that hypotenuse is OA square, right? So by Pythagoras theorem, OA square is equal to OB square plus AB square. OB square plus AB square, right? So OA is 4 centimeter, that is 4 square is equal to 5 square plus AB is 5. Sorry, OB we don't know, right? AB is 5. Next, 16 is equal to 25 plus OB square. So OB square is equal to 25 minus 16. That is equal to OB square is equal to 25 minus 16 is 9. So OB square is equal to 9. OB is square root of 9. That is OB is equal to 3 centimeter. Yes, over. So next question is, In the figure, O is the center of the circle. If AOB is 100 degree, then angle OAB is equal to, yes. So what they have given? Angle AOB is 100 degree. Right. Then AOB is 100 degree. Sorry. So next question is, in the figure, O is the center of the circle. If angle OAOB is 100 degree and OAB is equal to, see in one triangle, the sum of internal angles is 180, right? So one angle is 100 means 180 minus 100, that is equal to 80. If one angle is 80 degree, one angle is 100 degree, that means other two angles are 40 degree and 40 degree. Yes or no? 40 degree and 40 degree. That means option C is right here. Okay. Option C is right. Next one. The angle between the tangent and the radius drawn at the point of contact is 90 degree. The angle between the tangent and the radius drawn from the point of contact. See, this is a circle and this is a center O and this is a tangent. Call this as point P. Now you are drawing a PA as a tangent here. Okay. So now here radius and tangent, the point of contact between radius and the tangent, that is a 90 degree here. It makes right angle, that is 90 degree. The maximum number of tangents that can be drawn to a circle from an external point is 2. Okay. See, this is a external point. Here you can draw 2 tangents, right? So 2. In the figure O is the center of the circle. PA and PB are tangents. So this is also we did right. Okay. AOB is, see here, AOB is 100 degree. Okay. Then APO they have asked, right? So APO means the angle between the tangent and angle between the radius is 180 degree. That is APB plus AOB is equal to 180 degree. Right? Now, APB we don't know. APB is equal plus 100 is equal to 180 degree. So now transfer this 100 to this side. So angle APB is equal to 180 degree. 180 degree minus 100 degree. That is equal to 80 degree, right? So 80 degree is the value of APB. But what we want APO. So if APB is 80 degree, that means this is 40 degree and this is 40 degree. Yes or no? That means option D is right. In the figure, O is the center of the circle. PA is the tangent. If angle APO is 50 degree, then angle APO. So here APO is 50 degrees. See, this is point of contact P. make it is OPA. This is 50 degree. Okay. OPA. OPA is 50 degree. So what they have given? OPA is 50 degree. That means full internal sum is 180 degree. So 180 degree minus 50 degree. 180 degree minus 50 degree is 130 degree. So 130 degree means yes, this is sorry for the disturbance. Some network issue is there. Okay. So here OPA they have given, that is 50 degree. Okay. Now here it is a radius OA and PA is a tangent. So here it makes a 90 degree, right? That means angle POA plus angle PAO plus angle APO we want, right? Is equal to 180 degree. Why? Because POA plus PAO is equal to PO they have asked, right? So make it POA. So not this. They have asked about angle P, right? Make it is 50 degree. Now POA is 50 degree plus APAO. PAO is 90 degree plus APO. APO we don't know is equal to 180 degree. Now 90 plus 50. 90 plus 50 is 140 plus angle APO is equal to 180 degree. Transfer this 140 to this side. That is APO is equal to 180 degree minus 140 degree. That is equal to 40 degree. So option C is right. Okay. Next one. In the figure, PQ and PR are the tangents, right? If PQR is equal to 60 degree, PQR is equal to 60 degree, and PQ length they have given, that is 9 centimeter, and the length of QR, length of QR they have asked. See, my dear students, one theorem is there, that is, if you draw a tangent from an external point to the circle, then the length of that tangents are equal. Yes or no? See, if PQ is 9 centimeter, then PR is also 9 centimeter. Yes or no? If this is 9 centimeter and this tangent is also 9 centimeter, these two are equal. Next, one angle is 60 degree. That means this is also 60 degree and this is also 60 degree. So if all angles are 60 degree, then it is equilateral triangle. So in equilateral triangle, all angles are equal and all sides are equal. If PQ and PR are 9 centimeter, then QR is also 9 centimeter. Okay, QR is 9 centimeter. Next question. The tangents drawn at the end points of the diameter of a circle are intersect each other, coincide with each other, parallel to each other, or perpendicular to each other. See, tangents drawn at the end points of the diameter. See, this is a circle and this is a diameter. Okay, you are drawing one tangent here and one tangent here. And if you draw one diameter here and you are drawing one tangent here and one tangent here. Here, tangents are parallel to each other, right? So, tangents are parallel to each other. In the figure, AB, AD and DE are the tangents to the circle if AB is equal to 3 centimeters. See, AB is equal to 3 centimeter and DE is 4 centimeter and the length of AD they have asked. So, this full length we want. So, for that, here A is an external point and you are drawing two tangents, right? So, here AB and AC are two tangents and D is an external point and CD and DE are two tangents drawn from the external point to the circle. If AB is 3 centimeter, then AC is also 3 centimeter. Yes, this is also 3 centimeter. If DE is 4 centimeter, then CD is also 4 centimeter. Then AD is AC plus CD, right? AC value is 3 centimeter, CD value is 4 centimeter. So 3 plus 4 is 7 centimeter. So option B is right. Next one. So have you taken? Next one. Another two important theorems are there. That is, the tangent at any point of circle is perpendicular to the radius through the point of contact. The length of the tangent drawn from an external point to a circle are equal. Okay. Next. A quadrilateral ABCD is drawn to a circumference of a circle. Prove that this is a circumference. Okay. Prove that AB plus CD is equal to AD plus BC. Where is AB? AB is here. AB plus CD is equal to AD plus BC. Okay. Now, from the figure, D is an external point and DR and DS are the two tangents from an external point D, right? A is an external point. AP and AS are the two tangents from an external point A. And B is the external point. BQ and BP are the two tangents from an external point B. Now C is external point and CQ and CR are the two tangents from point C. Okay, so two tangents are equal. When you draw a tangents from an external point to the circle, then length of the two tangents are equal. This is one of the theorem, right? So two tangents are equal means here DS and DR are equal, AS and AP are equal, BP and CQ are equal, CQ and CR are equal, right? So DR is equal to DS, AP is equal to AS, and BP is equal to BQ, CR is equal to CQ. Now, call this as equation number 1, this is equation number 2, this is equation number 3, and this is equation number 4. Okay. Now, From 1, 2, 3, 4, DR plus AP. Now, consider this is LHS part and this is RHS part. Okay. So, add all LHS part, that is DR plus AP plus PP plus CR. Next, DS plus AS plus BQ plus CQ. Now, BP plus AP, DR plus CR, make one group, DAP plus BP and DR plus CR. Here DS plus AS and BQ plus CQ. BP plus AP. Where is BP? See, BP plus AP means it is AB. BP plus AP means it is AB, right? Like that, BQ plus CQ means it is BC, full line BC. CR plus DR. CR plus DR means it is CD, right? DS plus AS means AD, right? So AB plus CD is equal to AD plus BC. Yes, so prove that AD plus BC. Now, so next one. If a tangents PA and PB from a point P to a circle with center O, okay. So here P is external point and PB and PA are two tangents and center is O, are inclined to each other at angle 80 degree. Then POA is equal to, so for that, here OA and OB are the radius drawn at point of contact of the tangents BP and BQ. Therefore, OA is perpendicular to PA. See, this is OA is a radius and this radius is perpendicular to PA, right? So, it is like this. So, this is OA and this line is perpendicular to PA. Okay. So, PA, OA. Here it makes a 90 degree, right? Now, and OB is perpendicular to BP. Then, OBP. See here, OBP is equal to OAP. That means here it makes an angle 90 degree. Here also it is 90 degree. So that is equal to 90 degree. So B and A are 90 degree. In quadrilateral, OABP, right? Or AOBP. So this is a quadrilateral which is having four sides, right? Now, AOB is, in quadrilateral, how many angles are there? Four angles. That is AOB plus OBP plus OAP. Next one is APB. Okay. Now, the sum of all internal angles in the quadrilateral is 360 degree. Okay. So, AOB, that we don't know. OBP, see here, OBP and OAP is 90 degree. OBP is 90 degree, OAP is 90 degree, APB they have given, that is 80 degree. So, full internal sum is 360 degree. So, here 90 plus 90 is 180 degree. 180 degree plus 80 is 260 degree. So, 260 degree AOP plus 260 degree is equal to 360 degree. Transfer this 260 to this side. So, AOB is equal to 360 degree minus 260 degree. So, that is equal to 100 degree. That is AOB is 100 degree. Now, in triangle OPB and OPA. So, here two triangles are there. So, OPB and OPA. OPB and OPA. AP is equal to BP because these two are tangents from an external point and length of these two tangents are equal. OA is equal to OB, radius of the same circle. That two radius are also equal. Now, OP is common for both the triangles. So here three sides are equal. That means from SSS congruency rule, we can say that these two triangles are congruent. Now, angle POB is equal to POA because these two angles are equal, right? When these two triangles are congruent, then these two angles are also equal. So, POA is equal to POA. POB is equal to POA. Now angle AOB is equal to P. Angle AOB means POB plus POA, right? So what is the value of POB? POB is POA, right? Angle AOB is equal to POB means it is POA plus POA. So 2 times POA is there. So angle AOB is equal to 2 times angle POA. Now, angle AOB is 100. See here, angle AOB is 100. So 100 is equal to 2 times angle POA. Now, shift this 2 to this side. That means angle POA is equal to 100 divided by 2. 2 ones are 2 fives are. That means angle POA is equal to 50 degree. Okay, angle POA is equal to 50 degree. Understood? Yes. Yes, my dear students, shall we stop today's session? In the next class, we will solve some theorems and 3 and 4 marks questions. Okay? Yes, have you taken? Yes, thank you. Thank you very much.